Hi, in this video I'm going to discuss Edexcel IAL January 2020 Unit 4 paper WPH1401 from questions 14 to 19. In my previous video, I already discussed the questions 1 to 13 January 2020 Unit 4 paper, and the link or the URL for that video is given in the description of this video. So if you go to the description of this video, you can get the URL or the link for the previous discussions, questions 1 to 13. Okay, so also I'm going to upload more videos related to uh, teaching part regarding the theory explanations regarding other topics and other paper discussions also, unit 1, 2, 4, 5, 6 also. So if you subscribe my channel, then you will be able to get the notifications when I upload those videos. Okay, now we'll go to the questions now. Okay, question 14. A truck for go-kart is being built in a park. The design criteria, so they have shown a diagram of a track. So on either side there's a semicircle and the mid portion is a straight line. And mass of go-kart is given with the driver 185 kilogram, and the diameter of the curved portion on either sides will be is 30 meters. So for one design, the track is horizontal. So the mid portion is horizontal. As go-kart goes round the semicircular end of the track, centripetal force is provided by friction. We know that normally it's taught in the class. That means when an object moves, say something like when a vehicle moves on a curved path, the required centripetal force is provided by the friction between the road and the tire, right? So here the free body force diagram is given when in turning on a roundabout or turning on a curved track, the weight will act vertically downward. Normal reaction from the ground will act vertically upwards. So the friction between the tires or the wheels and the ground will act towards the center of the circular path. That friction will be the centripetal force. So showed that this design meets the design criteria. So we know the requirement. That means uh, the go-kart should turn safely at a speed of 9.72 meter per second, and the mass is given, diameter is given. So we will find the required centripetal force to turn the go-kart on that particular curved path, which has radius of 30 meters at a speed of 9.72 meter. We'll find the required centripetal force, and it's going to be provided by the friction, and the maximum friction that could be provided by the ground and the wheels is 1180 newtons. So if it wants to move safely without slipping, the required centripetal force must be lower than 1180 newtons. So if that happens, we can say the design criteria is correct. So we'll answer that question, A part. So we can say required centripetal force so F equal mv squared over r. So we know the mass of the go-kart 185 kilogram. The speed is 9.72 meter per second, and the radius of the curved path is 30 meter is the diameter. So it should be 15 meters the radius. Solve it, you will get 1162.65 2 Newton. So this is the required centripetal force to move on that curved path, which is provided by the friction. But the maximum friction between the wheels and the road or the wheels and the ground is 1180 Newton. So that means the friction is more than enough compared to the required one. So it is a correct design. So you can say since the required centripetal force is less than the maximum friction, the design criteria is acceptable. That's the answer for the first part, A part. Okay, so B part, this diagram is given. So there, the go-kart is going to move on a slope track, like a banked track, right? A second design uses a track that is banked at the semicircular ends. The track is banked at an angle of theta to the horizontal. So when the vehicle moves on it, there will be normal reaction R. The weight of the vehicle will act vertically downwards, mg. So if this angle is theta, the angle with horizontal, this angle also theta, you know, alternative angle. So this will be this red color line. The normal reaction is perpendicular to the slope. So this is 90. So this will be 90 minus theta. And this vertical line and the horizontal line, among them 90 degrees. So this will be, this angle will be 90 minus 90 minus theta, that will be theta. So this is 90, this angle between the vertical line and the horizontal line will be 90. This is 90 minus theta. So this is going to be theta. So when it moves on a circular path on this banked track, the center of the circular path will be somewhere here. The center of the circular path will be somewhere here. Okay. So the vehicle is coming out of the board. The vehicle is coming out of the board. It's going to move like this in a circular path, in horizontal circular path on the banked track. Okay. So here the required centripetal force is provided by the horizontal component of the normal reaction towards the center, the required centripetal. So here we assume the friction is negligible. So if you say the friction is negligible, the required centripetal force is provided by the horizontal component of the normal reaction towards the center will provide the required centripetal force. We assume the friction is negligible. So I can say since the friction is negligible, the required centripetal force F is provided by R sine theta. You know the component of R towards the O. O is the center of the circular path. R sine theta. This angle is theta. So away from the angle sine theta, R sine theta is going to be mv squared over R is the radius of the circular path. Okay. Then since it's moving on a horizontal circle, so the vehicle is moving on a horizontal circle on the bank, right? The vertical resultant force must be equal to 0. According to Newton's first law, there is no resultant force in vertical direction. So R cos theta minus mg must be equal to 0. That is R cos theta equal mg is the weight of the go-kart. Okay, so the question is we need to derive that equation tan theta equal 2v squared over gd, right? So here d is the diameter. So d is the diameter of the track. So I put it as r. So r is the radius. So that should be d by 2. So I can substitute instead of r, d by 2. Right. So that 2 will go up. We'll do that later. So r cos theta is equal to mg. Now we can divide the first equation by the second equation. That is r sin theta over r cos theta equal to m v squared over d by 2 over mg. So r will get cancelled. Sin theta or cos theta will be tan theta. Basic algebra. So this is d by 2. 2 will go up. You know 2v squared over m. M will get cancelled. 2v squared over md. Gd. That's the derivation. So this is the derivation for question number 14, B part, first part. Question number 14, B part, second part. Calculate the angle theta using the stated design criteria for this track. So we need to find the angle theta so that I can say tan theta is equal to the speed, the required speed is given in the previous page, that is 9.72 meters per second, 9.72 squared over 9.81 into diameter of the AB, the curvature of the diameter is given as 30 meters. So into 30, solve it and find the theta. You can use the calculator. So if you solve theta, you will get 32.7 degree. That's the slope of the bank track. Okay, so part C of this question, it says bank track will cost more to build. Suggest whether there are any significant advantages that would justify the cost. Yes. So if the track is banked, then what's the advantage? Now, if it is a flat track, the required centripetal force, what we calculated in the first part, that is in the A part, we considered only the friction between the wheels and the road, right? But in this one, we assume there is no friction. That is mentioned in the question, page number 13. It says that frictional force perpendicular is negligible, except at a particular speed v, the go-kart can follow the track without any friction. So here we assume there is no friction, and we found if the go-kart wants to move safely on a bank track, what should be the required angle? We found it 32.7. Right, C part, they're asking practically, will it be useful if you have a bank track? Yes, there will be friction also practically between the tires or between the wheels and the bank track. There will be friction also. So in this type of design, the advantage is the friction and the compound of the normal reaction towards the center both will provide the required centripetal force. So that means centripetal force will be larger. What's the advantage of centripetal force larger means the cart can move at higher speed without skiing or without slipping. That's the answer you should write. So I'm not writing the answer on the board. So it's a simple 2-mark question. So you can say on a bank track, there will be friction also. Therefore, the centripetal force will be provided by both friction between the wheels and the track plus the horizontal component of the normal reaction. Both will provide the required centripetal force, which is larger than the A part question. First answer. Second answer, therefore, since the centripetal force is larger, the cart can travel at higher speed without skiing, or it can travel at higher speed without slipping, you can say. So those are the 2 points expected for the 2 marks. Okay, question 15 about Rutherford alpha particle scattering experiment and J.J. Thompson's plum pudding model, which was that plum pudding model was accepted until Rutherford proposes his model. Later, they came to know that plum pudding model was a wrong model, right? So in 1908, Rutherford Geiger Master investigated the interaction of alpha particles. So you know the 3 observations and 3 conclusions related to Rutherford alpha particle scattering experiment. All the books have. First, we say the most of the alpha particles went straight through the gold foil, right? And we tell the conclusion for that most of the atom is empty space. Second, few of the alpha particles showed smaller deflection. So we say all the positive charges are concentrated at one point, the conclusion. Then 1 in 8,000 or very few of the alpha particles deflected more than 90 degree, or we can say 1 in 8,000 alpha particle almost bounced back. The conclusion, we say all the positive charges and most of the mass of the atom concentrated at the tiny central part of the atom. That is the conclusion regarding Rutherford model. So there he conclude that center part of the atom is called nucleus, which consists of massive mass, right? So that's the Rutherford alpha particle scattering experiment. But J.J. Thompson's plum pudding model, there he says in his model, the positive charge and the mass were spread evenly. So if you think about J.J. Thompson's plum pudding model, so if this is the atom, so positive charge and the mass spread out evenly throughout the atom. So that's the way he said. It's spread out throughout everywhere in the atom. Then negatively charged electrons were distributed within the atom. So distributed means that also spread out, distributed within the atom. So negative charges are distributed within the atom like this. So this is the J.J. Thomson's plum pudding model. But Rutherford's model, you know that it says that center part consists most of the mass of the atom, he said. Most of the mass of the atom is at the center part, he said, but he didn't say it consists of positive charge. He did not say that, but it consists most of the mass of the atom, which is much smaller compared to the size of the atom. And he said most of the atom is empty space, right? So now when we compare, the question is discuss the extent to which the results of alpha particle scattering experiments justified replacing the plum pudding model with nuclear model of the atom. So we'll think about one by one observations we obtained in the Rutherford alpha particle experiment. Their first observation, most of the alpha particles went straight through the gold foil. So here most of the alpha particles, those are traveling far away from the nucleus. They went straight because they did not experience sufficient electrostatic force to change their path. Right, so almost went straight in Rutherford alpha particle experiment. So that's the observation they had it. So when the alpha particles were fired through the gold foil, they got this one. Okay, so if they get this observation, can we say by using this observation, most of the alpha particles are passing through the gold foil without any deflection or with very little deflection, can we say that J.J. Thomson's plum pudding model is wrong? No, we can't say that, because in Rutherford alpha particle scattering experiment, if I take that is correct, yes, I can say most of the atom is empty, so they did not experience any electrostatic force, they went straight. But here also I can say this observation can say this model correct, because when alpha particle passes through the J.J. Thomson's model, they are going to experience electrostatic force everywhere. So that means, you know, alpha particle is positively charged particle, so this positive charge will push it, this will push it, this will push it, this will push it. So there in almost the alpha particle will not have any significant uh, repulsive force. So by using the first observation, most of the alpha particles went straight through the gold foil. I can't say, or we can't say, J.J. Thomson's plum pudding model is wrong. We can't say that, because that model also justified by using this observation. Then second observation also, few of the alpha particles showed smaller deflection. So the alpha particles, those are getting little closer, they showed smaller deflection, which is less than 90 degrees, maybe somewhere between 10 to 60 degrees or something like that, 10 to 90 degrees. So they can show here, those are getting closer. That also can happen, say, sometime when alpha particle comes somewhere here, something like this way, two positive charges can push it, so it could happen. So by using that also, I can't give a conclusion that is J.J. Thomson's model is wrong. We can't say that. Okay, so the third observation is the very strong observation to say J.J. Thomson's model is wrong, Rutherford model is correct, where what we see, very few alpha particles that we know, almost 1 in 8,000, they showed larger deflection, which is more than 90 degree or almost bounce back. That will never happen in J.J. Thomson's model, because if you want to have a larger deflection, means the alpha particles are positively charged particles, so they should have larger electrostatic repulsive force from the atom, the gold nucleus. So that means the gold nucleus means gold atom. So if the gold atom wants to give such a larger electrostatic repulsive force, alpha particle is positive, so the charge concentration inside the atom should be strong, and that means all the charges or most of the charges should be concentrated at one point to give such a large electrostatic repulsive force. Say That shows J.J. Thompson model is wrong, because here, since the positive charges and negative charges are scattered everywhere, they can't give such a large electrostatic force, whether it could be repulsive or attractive, whatever it is, but they can't give such a large electrostatic force on the alpha particle. But here, since if all the charges concentrated at one point, then they all together can exert larger force on the alpha particle, so it can have larger reflection or larger deflection more than 90 degree. Also, about the mass, when you roll a marble, the mass is m1. There's another marble m2 which is at rest. So if the mass of m1 is less than m2, when it comes and hit it, or if I say very much less, if it's very much less than m2, this is at rest, this is moving at a speed u1, what will happen? This mass will not move. This mass will not move. If its mass is much larger than this mass, that means the mass when this marble hit this marble, this will bounce back, but this will mostly remain at rest. Understand? But if this mass m1 greater than m2 or m1 almost equal to m2, then what happens? When this hits this one, both will move. Both will move in that situation. If this is greater than this, or both have almost same mass, when this marble hits this one, both will move after collision. But the other way, if this mass is much larger than, very much larger than this mass, what will happen? When it hits, this will remain at rest, only this will bounce back. That happened here. The particles, those almost had head-on collision, 1 in 8,000 particles, they almost bounced back. They observed that in the Rutherford alpha particle scattering experiment. The reason is the mass of the concentration of the center part of the atom is much higher, massive, compared to the mass of the alpha particle. So that's the reason matter collision caused the alpha particle to bounce back. Okay, so that will never happen in J.J. Thompson's plum pudding model. So actually, which observation gives a strong evidence for Rutherford model is the third observation. Very few of the alpha particles had a larger deflection greater than 90 degree, and very few almost bounce back is the strongest evidence to accept Rutherford's model is correct and J.J. Thompson's model is not acceptable. Okay, so these are the things you need to give it in your answer. So you have to say the first two observations will be valid to accept both model, whether this model or this model. Most of the alpha particle will go straight through the gold foil, whether this model or this model is correct. Even few of the alpha particles can have deflection less than 90 degrees. That can happen in both models. But the last observation is the strong evidence to say this model is not acceptable. This is the correct model. Again, I'm telling it because the alpha particles to experience larger electrostatic repulsive force, to have such larger repulsive force, the charge concentration inside the atom should be strong and should be put at one point. All the charges should be concentrated at one point to give such large electrostatic repulsive force. Another thing we must know, very few of the alpha particles, 1 in 8,000, had almost bounced back. Matter-matter collision. To have such collision, matter-matter collision, as I explained here, the mass of the center part called nucleus should be much higher, massive, compared to alpha particle. Almost all the mass is concentrated at the center of the atom. Okay, so this is the answer you should say. So from that observation, we can say J.J. Thompson's model is not acceptable. Rutherford model is acceptable. So I'll write the answer now. Okay, so answer for this question, it is 6-mark question. So give it on the board. Okay, question 16. Some spiders may be seen suddenly moving up in the air even when there is no wind. This happens when they let out strands of web. The spiders are pulled upwards as the electrically charged strands of web interact with the Earth electric field. Yeah, Earth has electric field. The reason is, above the Earth there is ionosphere. The cosmic radiation hits the air particles at certain height, so these air particles lose their electron and they become iron. So when you consider this is the Earth, at a particular height above the Earth, there is an iron sphere, right? That means ionosphere. That means due to the cosmic radiation, the air particles got ionized by losing their charges, so they become positively charged. So Earth has some ions with negative charges. So the electric field from the positive charge reaches the Earth. So when you consider a smaller region, it looks like the field lines are parallel. So it looks like the electric field on the near the surface of the Earth is uniform. Okay, so the average electric field is near the surface of the Earth is 120 volt per meter, which is downwards. The reason is from positive to negative, right? State with reason the polarity of the charge on the strands of the web. So uh, they are saying the electric field is downwards. So electric field is downwards means the highest position, the ionosphere should have positive charge, Earth should have negative charge. And also they are saying the strands experience force upward direction. That means they are experiencing force opposite the direction of field lines. So the strands should have negative charge. So A part you can say the strands should have negative charge since they experience electrostatic force opposite to the direction of field lines. So field lines are towards the Earth, but the strands are experiencing electrostatic force upwards, which is opposite to the field lines, means the strands should have negative charge. Okay, B part. A spider moves upwards after letting out a strand of web. Determine the initial upwards acceleration of the spider. So the mass of the spider is given, total magnitude of charge on the strand is given. So we need to find the initial acceleration. Simple. We'll consider the free body force diagram, the forces acting on the spider. Then we'll use F equal ma. So we consider the spider with a strand as one object. So the forces acting on them, the mass of the strand is not given, so it's negligible. So the total mass downwards, the weight will be the weight of the spider, which is mg. There will be electrostatic repulsive force from on the strand. So the total force on the strand upwards due to the electrostatic force is Fe. So the spider is on the strand. So both together we are taking one object. So I don't need to consider the normal reaction here because I consider both as one object. So the downwards is the weight of the spider. Upward is the electrostatic force acting on the strand. So spider is on the strand. So the total object when it comes to spider and the strand, the upward force is electrostatic force. So when it comes to both together, the resultant force should be upward, F equal ma. So that is electrostatic force minus mg equal ma. So the electrostatic force is given by F equal QE. We know the charge on the strand 3 into, I can say QE minus mg equal ma. The charge is 3 into 10 to the power minus 7 into electric field strength is given 120 minus mass of the spider 3 into 10 to the power minus 6 into 9.81 equal to 3 into 10 to the power minus 6a. Find a. That's the acceleration. That will be 2.19 meter per second squared. Okay, this is the B part. C part. The Earth has an electric field because charge is distributed over its surface. Determine the quantity of charge on 1 meter squared of the Earth's surface which would cause an electric field of 120 volt per meter on its surface. Clear, no closer to the surface. You should assume that the charge is distributed evenly. So if the charge on the earth is distributed evenly according to Gauss law, the Gauss law not much used in Edexcel, but anyway, we can assume the whole charge is concentrated at the center when the charge is distributed evenly on the surface of the sphere, surface of the earth. So I can use Gauss law. So in that law, it says we can assume the whole charge is concentrated at the center of the sphere, center of the earth. So I can say the electric field strength. I can assume the earth, the charge on the earth as a point charge at the center. So we can say E equal Q over 4 pi epsilon naught r squared. So if I consider the earth, the radius of the earth is r. I can assume the whole charge on the surface of the earth is concentrated at the center. So I'll assume the charge is concentrated at the center. So the electric field strength on the surface of the earth is given by E equal Q over 4 pi epsilon naught r squared. So electric field strength, we know. We need to find the charge per unit area. We know the surface area of a sphere A is equal to 4 pi r squared. So 4 pi r squared is there. So I can say cross multiply E into epsilon naught is equal to Q over 4 pi r squared. So I need to find this quantity, charge per unit area. So I don't need to find the Q. Okay, I don't need to find the Q. I can find Q over 4 pi r squared directly. So Q over 4 pi r squared charge per unit area is the question, which is E into epsilon naught. E is 120. Epsilon naught, you can find it in the data sheet. That is 8.85 10 to the power minus 12 farad meter. So to solve, you will get 1.06 coulomb per meter squared. Okay, question 17. A student is designing a night light for a child. When switched on, the night light should come on brightly and its intensity should then gradually decrease to zero. The time taken for the light intensity to decrease to zero should be as close as 10 minutes as possible. The time must not be less than 10 minutes. Must not be less than 10 minutes. So the diagram shows this one. So what's happened actually in this circuit, when the two-way switch, when it is connected to the left side, the capacitor will get charge 12 volt. It will get the maximum charge 12 volt. The maximum voltage 12 volt. Then LED is going to emit the light. That is going to be the night light, is the LED bulb. So when you connect this to this way, when the switch is connected to the other side like this, so the capacitor, which had initially 12 volt, is going to discharge through the both resistor R, which has 860 ohms, and the LED, which has constant resistance. They are saying assume, in this calculation they asked to assume the resistance of the LED 340 ohms. So the capacitor is going to discharge through this circuit. So the current flow during the discharge, current will flow through both 860 ohm and 340 ohm, that is the LED bulb. Okay, so here it is initially V0 12 volt. So we don't want this part now, it's got charge. Now we are discharging, the light is on. Means the capacitor is going to discharge through the circuit on the right side, this part. Okay, so the question is, capacitor with following. Now the student uses light emitter diode and the resistor, the LED stops emitting light when the potential difference across it falls to 1.4 volts. So the minimum voltage across the LED should be 1.4. Until that, LED will emit light. So from 12 maximum to 1.4, it will emit light. So when the voltage across the LED becomes 1.4, it will stop emitting the voltage, emitting the light. Okay, so the student assumes the LED has a constant resistance 340 ohms. Capacitors with the following capacitances that are given 0.5 farad, 0.51, 0.54, some values are given. Determine which capacitance the student should use. Resistance are 860 ohm. I already showed it on the diagram. So the idea here, now when you switch on the light, that means when the two-way switch is connected here, the voltage across the LED won't be 12 because there is voltage drop across the R also. So what could be the initial voltage across the LED we don't need, but the voltage across the LED, when it becomes 1.4, it will not emit light. So that means when the voltage across the LED becomes 1.5, 1.4 volt, what will be the voltage across the capacitor? Because we know that the voltage supplied by the capacitor is going to divide it across the resistor and the LED according to potential divider method. According at the ratio of their resistance, the voltage will be divided. Voltage across the capacitor will be divided across the resistor and the LED according to the ratio of their resistance. So we will find like this, we have equation V equal V naught e to the power minus TORC only for the capacitor, not for any other components. Okay, so we are going to use that equation for the capacitor. V equal V naught e to the power minus TORC. You know the equation. We can use this equation only for capacitors, right? So I know the initial voltage of the capacitor is 12 volt. When the voltage across the LED becomes 1.4, it's going to switch off. When the voltage across the LED is 1.4, what could be the voltage across the capacitor? I can find it by using potential divider method. So the V, the voltage across the capacitor, becomes that particular voltage, the light will switch off. The time duration should be not less than 10 minutes. Okay, so we are going to do that way. So I can say when the voltage across the LED is 1.4 volt, the voltage, I can say VC across the capacitor could be found by using potential divider method. You can write this in the answer paper or you can leave it just for your knowledge. I'm writing that. Okay, what could be the voltage across the capacitor? So I can say the voltage across the capacitor VC is the voltage across the capacitor into that resistance 340 over 340 plus 860 is equal to 1.4. That's the voltage across the LED. We'll find the VC now. So that will be 4.94 volt. So the LED will emit light when the voltage of the capacitor drops from 12 volt to 4.94 volt. This will emit light, but the time duration should be not less than 10 minutes. So we'll use this equation V equal V naught e to the power minus TORC. So V means VC, that is 4.94. V naught 12 e to the power minus 10 is the minimum time, 10 into 60 over RC. We'll find the RC first. So find the RC. You will get RC to solve it. You know how to solve. Take both side natural logarithm and solve. You know how to solve it. RC will become 676. Then C will become, if you substitute 1000 R is the total resistance, where R is the total resistance because capacitor is discharging through both. So R is both 860 plus 340, that is 1200 ohms. That is the R, total resistance of the discharging circuit. total resistance of the discharging circuit 860 and 340. So if you substitute that, 676 over 1200, you will get 0.56 farad. But there's no such answer, 0.56. But we know the time should be not less than 10 minutes. So time should be not less than 10 minutes means the capacitance should be more than this value, because I took this value 0.56 when the time is 10 minutes, equal to 10 minutes. When I substitute, I got this value, but the time should be more than 10 minutes means if the numerator increases, denominator should increase. So the acceptable value when we choose from the given values should be more than 0.56. So we can say 0.58 farad. So correct capacitance, the required capacitance 0.58 farad, because 0.56 is not given in the combinations. So 0.58 farad, little more than this much. That's the answer. Okay, question number 17, B part. In practice, the resistance of the LED does not stay constant. So in the previous question, we took the resistance of the LED is constant, but practically it's not constant. So you know the current voltage graph for diode or LED, the same shape. So here you can see when the voltage increases, current increase, the graph is turning towards the current axis means the resistance is decreasing when the voltage increases. So other way, if I say when the voltage decreases, resistance is increasing. I can say when the voltage increases, you can see the graph is turning towards the current axis means resistance is decreasing. So the other way, when the voltage decreases, resistance will increase. Okay, so the question is explain how the behavior of the LED shown in the graph will affect the time taken for the light intensity to decrease to 0. So the light intensity decreases when the voltage across the LED becomes 1.4 volt. So what happens when the voltage across the capacitor, when the capacitor discharges through the right side circuit, the LED bulb emits light. So the voltage across the capacitor will decrease. When the voltage across the capacitor decreases, what happens? The voltage across the LED also will decrease, because voltage across the capacitor is divided across the resistance R and the LED according to the ratio of their resistance. So when the voltage across the capacitor decreases, voltage across the LED also will decrease. When the voltage across the LED decreases, resistance of the LED will increase. That means time constant of the discharging circuit, will increase. What do you understand by the time constant increases means it will take more time to discharge further. So when the time constant increases, you know the definition, the time constant is the average time taken to drop the voltage to the 37% of the initial. There's a definition, but we know that higher the time constant, greater the time to discharge. So the capacitor will take more time to decrease further, means the bulb will remain on for longer than 10 minutes. That's the answer you should give. I'll write the answer now. Okay, part C, question number 17. The student states a capacitor is being used in this circuit. The function of the capacitor is to store electric charge. Explain why this is not a complete description of the function of the capacitor. So actually, when you are storing charge means actually what happens, it's okay, it stores charge, but actually on one plate of it. So when you consider the whole capacitor, there is no storage of charge. So what happens during the charging process? You connect a DC power supply. So when you connect a DC power supply across the capacitor, what happens? The electrons will be transferred from one plate to the other plate through the power supply, or will be transferred, electrons will be transferred from one plate to the other plate through the external circuit. And battery does work. Work is done on the capacitor when the electrons are removed from one plate and when the electrons are added to the next plate. There should be work done against the electrostatic force. So according to the law of conservation of energy, a certain portion of the work done will be stored in the capacitor in the form of electrical or electrostatic potential energy. So actually, capacitor stores electrostatic potential energy, not the charge, because the amount of charge on the positive plate, the magnitude of the charge on the positive plate and the magnitude of the charge on the negative plate are the same magnitude but opposite side. So when you think about the whole capacitor, the charge is zero. So we can't say capacitor stores charge. Actually, it stores electrostatic potential energy. Even when you think about DC battery dry cell, they are due to the chemical reactions, the positive ions and the electrons are separated inside the cell due to the chemical reaction. So we don't say dry cell stores charge. There are also charges are there, but when you connect a wire, the electrons flows through the external circuit that we call current flow from the dry cell. So there we say it stores chemical energy. The same way, capacitor stores electrostatic potential energy or electrical potential energy, not the charge, because total charge is equal to zero. I'll write the answer for that. Okay, question 18. The photograph shows a demonstration AC generator used in a school. So there's a photograph is given. The handle is used to rotate the coil between the magnetic poles. So the magnets are fixed. The field line direction is fixed. A coil is going to rotate within the field lines when the handle is rotated. When light emitting diode is connected across the coil, the LED flashes on and off as the coil rotates. Explain this observation. Okay, so why the LED bulb flashes on and off? So we can say when the coil rotates, the magnetic flux linkage with the coil is changing. You know the magnetic flux linkage with the coil is given by. So if the coil is kept like this, it could be a circular coil or rectangular coil, whatever it is. If this is the coil, and if the field lines are the magnetic field lines are towards right, something like this. So this is it. The coil might consist of n number of turns. It might have capital N number of turns. The total area of the coil is A. And we should consider the angle between the direction of the magnetic field and the coil. So how do we consider the angle between the coil and the magnetic field? Normally, the angle is measured with the normal to the plane. So we consider a unit vector, or we consider a normal to the coil of the plane of the coil. If I consider this is the normal to the plane of the coil, so this angle is theta. If I consider the angle between the normal to the plane of the coil and the magnetic field, if it is theta, then the magnetic flux linkage means we should consider the field lines, those are perpendicular to the plane of the coil. So if the angle between the direction of the magnetic field and the normal to the plane of the coil is theta, so the magnetic flux linkage is given by, so the magnetic flux linkage with the coil is given by phi equal B cos theta. So we need to consider the component of the field lines perpendicular to the plane of the coil, V cos theta into area of the coil into number of turns, that is phi equal VAN cos theta. That is the magnetic flux linkage with the coil. Okay, so I can go a little further, but not in the syllabus. Normally students ask, you can see the next question, page number 21, the induced voltage is sine format. So the students ask, when the coil rotates at constant angular speed, why the induced voltage forms a sine format with the time, or why the induced voltage varies in the sinusoidal shape. So it's not a big issue. I'll continue, but not in the syllabus, just for a few minutes. So this is the magnetic flux linkage with the coil. And if it is rotating, if this is the plane, this is the axis of the coil, and if it is rotating about this axis at constant angular speed, I can say omega equal theta over t. So theta equal omega t. So I can substitute VAN cos omega t. Okay, I'll just do, not in the syllabus. So induced EMF is given by minus d phi by dt. That means differentiate this one. So if you differentiate this one with respect to time, you know the differentiation. Those who are doing maths, don't worry, not in the syllabus. I'm just doing for students, those who are interested. So induced EMF is given by E is equal to, differentiate this equation, Bn cos omega t. So B is constant, A is constant, N is constant. So I can say minus Ban d cos omega t over dt. So it's going to be minus Ban omega. When you differentiate cos omega t, it will become omega. If you differentiate cos, it will be minus sine. So it's going to be Van omega sine omega t. That is the induced voltage. So this form, you can see if it is rotating at constant angular speed, omega is constant, N is constant, A is constant, V is constant. So I can say this as induced voltage. I can say epsilon or V induced voltage. Normally we use V or epsilon. I use V equal V naught sine omega t. Where what is V naught? V naught is equal to Van omega. So the peak voltage V naught depends on the angular speed, depends on the frequency. That's a question asked in this part, but we don't use these equations in A level, but this is the actual explanation. So you can see the peak voltage depends on angular speed. If you maintain the angular speed constant, frequency of rotation constant, you will have constant peak. So this is a sine shape. That's the reason you can see page 21, the induced voltage is varying according to a sine curve. V against time graph is a sine curve. Okay, so you know when the frequency or when the omega becomes half, they're asking there, when explain the changes in the graph when the angular velocity of the coil half. So when the angular velocity becomes half, omega becomes half, what happens? The peak will become half of it. You can say peak will become half of it, but we don't use these equations in A level. We will explain in some other simple way. When I discuss it, I'll show that. So don't worry about that derivation, calculus, not in the syllabus. Just I did it for students, those who are interested. Right, okay, we'll come back to the question, A-level standard. Okay, so here they ask to explain why the LED switch on and switch off. So 4-mark question, you can say, when the coil rotates, the magnetic flux linkage with the coil will vary. And then you can say the rate of change of magnetic flux linkage with the coil gives the induced voltage. Then you can say when the angle between the coil and the magnetic field varies, the induced voltage also will change and its direction of also will change. So the coil is in a complete circuit, there will be current flow. Therefore, the LED could be either in forward bias or reverse bias across the induced voltage. When the LED is in the forward bias, it will emit light. When it is in the reverse bias, it will not emit light. That's all. So you know the equation I derived it, VA and omega sine omega, just I derived it, is a sine format. So sine format means induced voltage is going to have both positive and negative sides. That means the direction of the polarity of the induced voltage is going to change. That is the AC voltage. So the direction of the induced voltage changes means direction of the induced current. When that induced voltage flows through a complete circuit, the direction of the induced current also will change continuously. That is called AC current. So when current flows through, AC current flows through LED, which is fixedly it kept at one particular orientation. So the direction of the current could be either forward bias and reverse bias depending on the direction of the current. So when the diode is in forward bias, there will be current flow, it will emit light. When it is in the reverse bias, it will not emit light. Okay, so that's a simple answer. I'll write the answer now. Okay, question 18, part B. The output potential difference V of the generator is recorded using data logger and the graph is produced of V against time. So you can see that it's a sine shape. I already derived when I started this question why the induced voltage is sine shape. The derivation is not in the syllabus. I already showed that anyway. Add to the graph to show output if the angular velocity of the generator coil is half. So when then next part, explain the changes in the graph when the angular velocity of the coil becomes half. You know, when the angular velocity becomes half, the time taken for one rotation, you know, omega equal 2 pi over t, omega equal 2 pi over t. When this becomes half, the time taken will become double. So that means here you can see the one period is 0.2 seconds according to the given graph. So that should become 0.4 seconds. Same sine shape. The time for one full rotation will be 0.4 seconds. That change will occur. Also, the peak will become half. I already derived it. V equal V naught sine omega t. V naught means V A N omega. I derived it. So omega becomes half. The peak voltage also will become half. The explanation they are asking. So we can say next part, that is question number B part, second part, explain your graph. So why it becomes the period double, you can say omega equal 2 pi over t. When omega becomes double, the time period will become, sorry, omega becomes, when omega becomes half, time period will become double, you can say. So time period, that's the way you drew it, graph. One explanation. Why the peak becomes half, that you should say when the omega becomes half, the rate of change of flux linkage will become double. That's the way we have to say. The rate of change of also will become half, sorry. Rate of change of flux linkage also will become half. Therefore, the peak will become half. I'll write the answers and I'll draw the graph also. So the black color graph shows the given graph with a period of 0.2. So the red color graph, you can see the peak according to the given graph, the peak voltage is 5 volt minus 5 volt. Here 2.5 volt peak voltage. The one full cycle takes 0.4 seconds, that is double the time. So the explanation you can say like this. Okay, question number 18, part B, third part. The coil rotates in a uniform magnetic field at the original angular velocity. So the earlier angular velocity, what is given on the graph, right? So there you know the time period is 0.2 seconds. that angular speed. Okay, so the average magnitude of V, so the induced voltage varies sinusoidal according to sine shape. So the average, the peak voltage, you can see from the graph, peak voltage is positive 5 or negative 5. Anyway, you know the reason. But the question says the average magnitude of the voltage given on the graph, average voltage is 3.2 volt. Okay, so students usually ask how that numerical value 3.2 is obtained by the examiner. So 3.2 volt is average volt. What do you mean by average voltage? Okay, so that is not in your syllabus. Again, there is an equation for average voltage that is given by, not in your syllabus, V average is equal to 2 over pi V peak. V naught is the peak voltage. If you substitute there, you will get the average voltage, what is given as 3.2. You don't need how they get it. Sometimes students ask when we are doing this paper. So for those students, I am telling this. So 2 over pi, substitute 2 over pi into the peak voltage is 5. Substitute, you will get 3.2 volt. So that is the average volt. How this equation is obtained, not in your syllabus, we can derive it. Anyway, you don't need that derivation. That's the way the average voltage is obtained. Okay, but in your syllabus, what we say, the induced EMF or induced voltage, change in flux over time taken. So change in flux over time taken gives actually, it could be average voltage or voltage at an instant. You can see the graph given on page 21. The voltage is varying at every instant. Zero time. When the time t equals 0, the voltage is 0. When the time increases from 0 to 0.05 seconds, that is 1/4 of the period, you can see continuously, step by step, the induced voltage is increasing. So, according to Faraday's law, the induced EMF is given by change in flux over time taken. When the time taken, when we consider very small, we say when the delta t almost become equal to 0, very small time interval. During that time interval, when we think about the change in flux, you know, when delta t becomes 0, it, according to calculus, it becomes d phi by dt. Understand? So when we consider very small time, you will get the instantaneous induced voltage at an instant. But when we consider like this induced EMF equal phi 2 minus phi 1 over time taken, this will give, if the t is reasonably larger, not like this, if the t is larger means you will get the average induced EMF. Okay, change in flux over time taken gives the average induced voltage. It won't be the induced voltage at an instant. It won't be the induced voltage at an instant. That will give the average induced voltage. So when we consider, when the coil is, the plane of the coil is perpendicular to the field line, the magnetic flux linkage will be the maximum. So I can say there the phi max, the maximum flux linkage, that I can say phi max equal to BAN. When the plane of the coil is perpendicular to the field line. That means the normal to the plane of the coil, normal to the plane of the coil is parallel to the field line. The theta will be 0. What we used theta earlier in the explanation A part, theta will be 0. That time, maximum flux linkage BAN. From that position, when the coil rotates through 90 degree, that means when the coil takes 1/4 of the period to rotate, the coil plane of the coil will become parallel to the field line. So the flux linkage will be minimum, that will be equal to 0. So average induced EMF, I can say V average, induced EMF, I can say V average is equal to phi max minus phi minimum over time taken. I told this happens maximum to 0. That happens when the coil rotates through 90 degree, 1/4 of full rotation. That means the time period is 1/4 of the period, T by 4. So now we can use this equation to find the unknown quantity, that is number of turns, right? So here we know the average, that is 3.2, 5 maximum, VAN, 5 minimum, 0, T by 4. We'll substitute the values. B, we know the value of B given magnetic flux, that is 0.083. Area of cross section 0.0048. Number of turns n minus 0. I don't need to write minus 0, not necessary to write because minus 0, same answer. T by 4. I know the time period 0.2 seconds. See the graph 0.2 millisecond. I think 0.2 seconds. Sorry, 0.2 seconds divided by 4. So everything we know, only n is unknown. Solve for n, you will get 401.6, so 402 turns. That's the answer. Okay, question number 19. The first cyclotron was created by E.O. Lawrence in 1931. So they are asking to derive that equation. The time period is 2 pi m O BQ. So it's not a big issue. All the books have. Anyway, I'll derive it. Question number 19 is first part. So you know cyclotron has magnetic field, and the magnetic field provide the force on due to the magnetic field acting on a charged particle is given by B F equal BQ is sine theta, but the field lines, the direction between the direction of the magnetic field and the velocity will be 90 degree. So the magnetic force acting on a charged particle in cyclotron will be BQV. So that will be the centripetal force. So I can say the magnetic force F equal BQV will be the centripetal force. So mv squared over R. So here I can say R equal mv over BQ. It's moving on a circular path, so at constant angular speed. So V equal to 2 pi R over time taken T. Substitute here M times 2 pi R over T over BQ, that is R. R and R will get cancelled. Make the T subject. You will get T equal 2 pi M over BQ. That's the answer, first part. Second part, in Lorentz cyclotron, uh, an alternating potential difference was used to accelerate particles to high energies. Explain the significance of the expression obtained by the Lorentz. So you know that this time period, you can see the radius of the circular path. You know when the particle moves on cyclotron, whenever it crosses the gap between the D shapes, you know only in the region between the D's, electric field is applied. So the particle, when it crosses the gap, it will gain kinetic energy due to work done by the electric potential. So the speed will increase, radius will increase according to this equation. But even when the radius increases, the time taken by the particle to complete one's full circular orbit is independent of the radius, independent of the time period. So this is very useful in design of cyclotron. That's the question they're asking. So explain the significance of the expression, this expression obtained by Lorentz to the operation of cyclotron. You can say that when uniform electric field is applied only in the region between the D-shaped cylinders, and when the particle crosses the gap, the polarity of the D's should be in proper position. Say, for example, if the positive particle is crossing the gap, the D, which is receiving the positive particle, should be negatively charged, and the particle from where it's leaving should be positively charged. It will go inside the first D-shaped cylinder. When it comes back to the gap again, the polarity should be switched. So every half cycle, the polarity of the D's should be switched regardless of the speed of the particle and radius of circular orbit of the particle. So that means the time period of the particle should not depend on the speed and the radius that is obtained in this equation. So if we maintain the time period of the AC signal same as the time period of the particle, then we can maintain the polarities properly whenever it crosses the gap, and we can increase the energy of the particle. So that's the answer you should give, because time period does not depend on the speed and the radius of orbit of the particle. Okay, last question, question number 19, B part. In a cyclotron in which Lorentz expression applies protons who are accelerated to a speed of 1.5 10 to the power 7 meter per second, determine the time taken to accelerate a proton to this speed from rest. So magnetic flux density given 1.6 Tesla, accelerating potential difference 13 kilovolt. So final speed is also given. So from rest, it's gaining the final speed of 1.5 10 to the power 7 meter per second. The question is how long it will take to get that speed inside a cyclotron, which has magnetic flux density of 1.6 Tesla, and the accelerating voltage across the gap is 13,000 volt. Okay, so here we know that when the particle completes one full orbit, it will accelerate twice, or it will gain energy twice, because when a particle moves one complete circle, it will cross the gap between the D-shaped cylinders twice. Imagine a particle is moving from here. So if it's moving like this, it has completed one full orbit. So it crossed the gap here, again here. So that means when it completes one full orbit, it will gain energy twice. And the time taken will be T equal 2 pi, T equal 2 pi m over B cube. That's the time taken for one complete orbit. Okay, so we know how much of kinetic energy it is gaining. We know the final speed, 1.5 10 to the power 7 a proton. So we can find how much of kinetic energy it is gaining. So we know gaining kinetic energy equal, that is provided by the work done by the electric potential, which is given by W equal QV. So the total gain in kinetic energy we can find half mv squared. V is given 1.5 10 to the power 7 all things squared minus initial kinetic energy 0. So we can find the gain in kinetic energy. That is by QV. How many times it should get QV? Say when it completes one full orbit, it will gain QV twice. Twice the work will be done on the particle. Like how many times, how many complete circles should it have to go through the cyclotron to get that energy? So that's the equation simple. So I can say gain in kinetic energy equal total work done by electric potential. So this is the question number 19, B part. So total work done by electric potential. So gain in kinetic energy half mv squared minus half mu squared. You know u is 0. Total work done when it crosses the gap once, the gain in work done by the electric potential QV. So if it completes one full orbit, it will gain the energy twice. So if I consider one full orbit, it will cross the gap twice. So QV into 2. How many orbits it's completed? Let it be n. How many orbits it's completing? Let it be n. So if I find the n, then time taken for one orbit is this much. Multiply this by n. That is the total time taken. Simple. So this is the gain in kinetic energy. QV is the work done by the electric potential when it crosses the gap once. We know if it completes one full orbit, it will gain, work will be done on the charged particle twice. So QE into 2 during one full cycle. How many complete cycles needed? I will find the end here. Then time taken for one full orbit is this much. What's the total time taken? This into n. That's the answer for this question. Simple. So we'll do it. So half into mass of the proton given in the data sheet, 1.67 10 to the power minus 27 into the final speed is given as 1.5 10 to the power 7 all things squared. Initially it was at rest, equal to Q charge of a proton 1.6 10 to the power minus 19. This is the mass of a proton. This is charge of a proton. The voltage applied across the D-shaped cylinders, 13 kilovolt into 2. So this is the energy gain during one full orbit into n number of orbits. Okay, find how many times should there be complete circles. That will be 45.2 complete orbits. So time taken for one orbit, t equal, so I can say total time equal t into n. So that is 2 pi m over bq into n. Substitute everything given, 2 pi. Magnetic field strength, the mass of a proton is given 1.67 10 to the power minus 27 over. Magnetic field strength is given 1.6. Charge is 1.6 10 to the power minus 19 for a proton, and we found it 45.2. I'll substitute 45.2. I can substitute even 45. I'll put 45.2. Solve it. You will get 1.85 10 to the power minus 6 seconds. That is 1.85 microsecond. That's the answer. Okay, so I hope this paper discussion is useful to you. The URL for the video where I discussed question 1 to 13 is given on the description of this video. From that you can see that first 13 question discussion for the first 13 questions. Okay, also I'll discuss theory and other past papers also. So to get notifications, if you like, you can subscribe my video. Okay, so thank you.